Hey everybody, today's lesson is on scale drawings, and I want to start here with a few definitions here, and then we're going to get into actually how to solve scale drawings, which is really nothing more than setting up proportions again. And then once we have that proportion set up, we're going to go ahead and cross multiply and divide. The first one here is up top is called a scale drawing. It says a scale drawing is a two-dimensional drawing that is similar to the object it represents. So a couple examples of what a scale drawing might be would be a map of any kind, like the map of the United States, okay? Where obviously we use a map because we can't actually draw a life-size scale of the United States. That'd be too large. So we come up with a map, maybe a road map, things like that, okay? Maybe a map of your bedroom. If you draw a picture of your bedroom to point out kind of where things are, where the bed is, where the door is, that would also be a scale drawing. Maybe a blueprint for an architect, someone who's designing some type of a building, or a carpenter, someone that's building a house, something like that, where they're going to draw up an actual drawing of the real life thing, all right? But it's a smaller version of it, okay? Part two, kind of the same thing, except we're talking about three-dimensional then. A scale model is a 3D model that is similar to the object that it represents. You can think of any model that you can think of, like a model car would be an example of a scale model. A model of the White House, possibly, could be a scale model, the White House. Maybe even a cell model, all right? I know you get a lot of people do this in science class where you build, actually a cell is so incredibly tiny that you can't draw a life-size representation of a cell, so what we do is we draw a larger model. Okay, so it doesn't always have to be a smaller version. It can be a larger version too. So you can draw a cell model where you can point out the nucleus and all those sorts of things. Okay, one of the most important things that we're going to talk about today is this one right here. What a scale is. Every scale drawing or scale model that you're going to have to do, you're going to either have to come up with a scale or they're going to have to tell you the scale. And you can see here, all it's going to be is a fraction. Okay, the scale is going to be a fraction. And what you have to remember is always the numerator is always going to be the drawing or model size or distance. So it's not the real life thing. The numerator is not the real life thing. It's either the drawing size or the model size or the drawing distance, the distance on a map from Neenah to Washington, D.C. It's the distance on a map. Okay, that's always going to be the numerator. The denominator is always going to be the actual real life size or the real life distance, okay? So let's just say we were talking about a map and we said that 2 inches on a map represents 500 miles in real life, okay? That would be an example of what the scale is. And if you can come up with the scale, well, that's just a ratio. We have 1/2 of our proportion already set up. We just have to fill in the other numbers. Okay, let's go ahead and do one. Example 1. A carpenter is building a house from an architect's blueprint. The blueprint has a scale of 1 to 42. Find the actual length of a wall that is 3 inches long in the blueprint. Okay, so when we do this, okay, scale drawings are just setting up proportions. So I can start by making my lines there. And just like when we were setting up proportions before, we always got to start by finding some type of a ratio. In this case, they're going to tell us the scale. The blueprint has a scale of 1 to 42. 1 to 42. Now, they didn't tell us what 1 and 42 are. Are they 1 inch to 42 inches? Is it 1 mile to 42 miles? But this is what we call writing a ratio without units. And when you write it without units, the one thing I'm going to mention is that I know that both of the labels are going to be exactly the same. Okay, if the top is going to be inches, the bottom would be inches. Now, they didn't necessarily tell me it was inches. I just know that whatever it is on top, it's going to be the same on the bottom. Okay, 1 unit compared to 42 units. Now, you can see here, all I have to do is now come up with my other side of the proportion. I'm going to know one of these two, either the numerator or the denominator, and the other one's going to be my variable. So I have to come up with one other number. And look at this, the last sentence says, find the actual length. Find the actual length of a wall that is 3 inches long in the blueprint. 3 inches long in the blueprint. So now we got to go back if we remember from the last page, what we said is that the numerator is always the, I almost messed up there. The top part, the numerator, is always the model size or the map size, okay? It's the model / map size. It is not the real size. And then the denominator is always going to be the real life size. And if you can keep that straight, then plugging in your numbers become really easy. First of all, the first thing I underlined here was find the actual length. Find the actual length. I'm looking for the actual real life size. Well, since the actual real life size is my denominator, I put my variable on the bottom. The second thing is the last part of the question here actually tells me, it says of a wall that is 3 inches long in the blueprint. 3 inches long in the blueprint. 3 inches long on the map. Well, the map size goes on top. So that's where I put my 3 inches. And then because I know that's inches, I know everything's going to be inches. Now that I have my proportions set up, we cross multiply and divide. So 42 times 3 is going to be 126. 126 divided by 1 is going to tell me that x is going to be 126, and that is the actual length of that wall. Find the actual length of a wall that is 3 inches long in the blueprint. Okay, 126 is our final answer. Okay, here's one for you guys to try. Okay, so set up your proportion, go ahead and solve it. Pause the video, try it on your own. Okay, so the question says a model of a space shuttle has a scale of 1 to 52. Okay, the scale. I always look for the scale first because the scale is going to be 1/2 of my proportion, 1 to 52. It says the space shuttle has a wingspan of 78 feet. So now here's my third number. I always need to have 3 numbers. Okay, the space shuttle has a wingspan of 78 feet. 78 feet. You just have to determine, is that the real actual size of the space shuttle, or is that the fake size? And then the question says find the model's wingspan. We're looking for the wingspan of the model. We are looking for the wingspan of the model. The model always goes on top. This actual space shuttle wingspan is 78 feet. That goes on bottom. Okay, and like always, we're going to go ahead, cross multiply and divide. 1 times 78 is 78. 78 divided by 52 is going to give me 1.5, and if I want to label it, I would label it feet. Okay, so on the model, it's going to be 1.5 feet, 1.5 feet. I know that the label's feet because without units, I know that both of those are the same, and if it's feet on the bottom over here, that's going to tell me that they're all feet. Okay, last problem of the day. One slightly different type of problem that we're going to be asked to do here. Example 3 says a sofa is 8 feet long. In a scale drawing, the sofa is 3 inches long. Find the scale of the drawing and write your answer A with units and B without units. Okay, so 2 things they're asking me to do here. Write a scale with units and write it without units. Well, if we're trying to write a scale is just a ratio. Okay, so let's look at our first couple sentences here. A sofa is 8 feet long. Okay, that's real life. Our sofa is 8 feet long. So that goes on bottom, 8 feet. In the scale drawing, the sofa is 3 inches long. In the scale drawing, the sofa is 3 inches long. Well, that's the fake part. Okay, so that's 3 inches long. Okay, well, look at this. 3 inches in the drawing compared to 8 feet in real life. This right here is what we call writing our answer, our scale, with units because we have inches and feet. Okay, now in the other examples you heard me talk about that, if I want to write something without units, I can get rid of the inches and the feet, but what we have to end up happening is they have to be the exact same units. Okay, it has to either be inches and inches or it has to be feet and feet. So since I know that there are 12 inches equals 1 foot, 12 inches for every foot, what I can do here is take this 8 feet and I can change it to inches by multiplying by 12. Okay, so that on bottom here, that's going to give me 96 inches. 8 feet is the same thing as 96 inches. And then these 3 inches can just kind of come along because I'm not changing the inches on top. So instead of saying 3 inches to 8 feet, I can say 3 inches compared to 96 inches. So instead of saying feet, I'm just saying inches. Okay? So now, if I want to change this to write without units, now that they're the same thing, I can just drop those inches off and say 3 to 96. And that is going to be without units. Okay? But of course, as you're probably thinking in your head, is that we're not done yet. Because because this is a ratio, just like any other fraction, if we can reduce, we want to do that. So I'm going to go ahead and reduce. 3 divided by 3 gives me 1. 96 divided by 3 is going to give me 32. So without units, it's going to be 1 to 32. Okay, so writing your scale with units and without units is the last type of question you're going to be expected to do. Okay, that's our lesson for today.